Hello, I want to talk about TensorFlow in this session, and also it's discussed in a Udacity deep learning course for the AI program. And TensorFlow is an end-to-end open source platform for machine learning provided by Google. And there is a very good guide how to install and launch the package in the course that I don't want to go through it to save time. And I really highly recommend you to have a look and check it out. Before we deep dive in the lab section, I want to mention two things in the which are features in the TensorFlow. First of all, in the TensorFlow org, you will find very good learning tutorials that it depends on the level that you want to go, even for beginners or even experts. So very good sources and examples of how to use this library. For example, here there is two examples. One is for beginner, the other one is for expert level. If you look at the beginner one, and this piece of code is very compact, and basically it creates a model, trains it. So import TensorFlow as TF, and then TF Keras dataset MNIST. Basically, this part is how the dataset is loaded to the MNIST, which is gonna be our dataset that we're gonna use later. And this is the load data part, and normalizing, because this is an image data set and it's a grayscale, so basically they're by dividing by 255, it's just normalizing it. And then you can create a model. It's very easy, like tf.keras.model, sequential. So we want to have a sequential model, so you can choose different types, right? And then the first, you can also define the layers right away. So the first layer is going to be a flattened layer, is a window of 28 by 28 pixels for the pictures. And the second layer is a dense. Dense layer is a layer which all the neurons are densely connected. We are going to have 128 neurons for here, and our activation is ReLU. And you can have, after that is added a dropout, which coefficient of 0.2. And then a dense layer for output with 10. Output is going to be our the number of the net neurons that we are specifying is going to be 10, and the activation softmax. So this is going to create your architecture. It's very straightforward and compact. And then you compile. Basically, we create a model. So your you choose your optimizer Adam here. Loss is a sparse categorical cross entropy, hard to pronounce. Make sure that pronouncing it correctly. And the metric is going to be accuracy. So this is going to compile and create the model. And then this is the model.fit. Basically, is going to train your model. Here is the X train and Y train and epochs, which is the training. How many times you want to train your model, which is 5. It's chosen 5. You can just give it any number you want. And the model.evaluate, then basically it's going to just test your model, see how accurate your model is. You see, in this very compact piece of code, you created a model, train it, and evaluate it. Also, TensorFlow gives you the freedom to deep dive and have more hands-on on deeper layer of code with, like, for example, in this expert level, you can see, you can even choose what kind of convolutional network you want to have, what other attributes of your network, how it's going to be, and also even how you want to start to train it. So after that, also training a model, training models, and feeding the data, and data intake is our computational and time consuming processes. So very good feature that TensorFlow provides us is you can save your model. Here basically you can use, let's say it's a model, and you can just model.save. You can just specify the name of the file you want, and it's gonna save your file. Also, you can, if you want, you can save like the weights manually, but to get to know more, I really recommend you go through this TensorFlow.org tutorials and learn more. And also you can load back your model, but Keras models.load model, and just load whatever you saved before. However, always keep in mind the model you're saving, the model should, and the model you are loading back should have the same architecture. So you need to make sure that you have the same number of nodes in each layer, and the number of the layers are the same. So you can save and load your models. So let's go through the lab. In this lab, basically, the data set which is used is not Minst, which is an open source database of the pictures of letters, and we wanted to reach to accuracy of 80%, which is pretty high. And another thing to mention, that basically NotMNIST is a very big data set which contains maybe 500,000 images, and we only are going to use 15,000 of them. 15,000, sorry, yes, and for the labels A to J. However, I already done the data intake part, which is a lot. So when you launch the notebook, and another thing to mention, I'm running this notebook in a GPU machine in AWS, so that's fast. Keep in mind, if you're gonna run it in a local machine, it might take way longer. However, the first part is just the data input. Is importing the required libraries, and let's go down. The second part, basically, these pictures are zip. So this chunky piece of code is supposed to unzip the files for you. Sorry. So it's gonna download the files and unzip them. Sorry, the first part was the downloading part. The second part here is unzipping them. I already ran them and it's done. So the first problem was asking to normalize the input by using the min-max scaling. The formula is given here. So it's a grayscale image. So I want to show you. So the A is a lower limit, B is a higher limit of your normalization range. X are current data, X minimum is the minimum of the values that X can have, and max, X max, X min, this is going to be the range of the whole values you're going to have. So it's pretty straightforward, and here are actually it's asking for us to normalize the values between 0.1 to 0.9, and we already know our lower and upper limit, and also we know our minimum value of a grayscale pixel is going to be 0, and maximum is going to be 255, and it's pretty straightforward. You just do the math, and you see it's almost the same as you would do in a not almost, it's the same as you do in a Python script. So I already ran this and the test is passed. Also we need to encode the labels, which are the tags to the image. Like this is A, this is a B, whatever. And then we normalize them. This is going to check if it's not normalized, normalize it one more time. And here is to save the data. So this piece of code is gonna save your whatever basically we took in bunch of pictures as a input data, and it's gonna save them in a file called pickle. We can name it different if you want to. However, I already ran this, and then let's go to the main section, which is when we start using actually TensorFlow. So we are gonna import our data, which is our normalized, saved, grayscale pictures, and math, non-phi, TensorFlow, and this one is for like having this progress bar and plot from the math library. So here is gonna load the data to from Pickle to our current. We're gonna just create a bunch of variables to get the data input. So we need to create a neural network which only is gonna have two layers, one flattened layer of 28 by 28 and the weight and biases, and one output layer of 10 outputs, because we have 10 letters here, right, from A to J. And then I want to just skip this, get to the code part. Here the images are 28 by 28, so it's gonna give us the product of it, which is 784. This is the features that we're gonna get per image. So, and we have 10 labels. It was very straightforward. I already did it. So you just create this placeholder for, we want it to be float 32, and later we can do the mathematical computation later. And also placeholder for the labels and float as a float 32 as well. So later we need to create the weights and biases. So we have the truncated normal of feature count and label count as weights. So, and the another one for variables, basically we are just feeding it a matrix of zeros. And we don't modify this. I already ran this and the test passed. So the only thing it tested was this part, placeholder, and how we create the variables. And then later we, so here we only create the accuracy function. So I already tested that. This is the main part. Basically, we see our neural network functioning. Here, we are gonna have deciding how big our batch sizes are. We decide 128, and okay. Our problem is asking for us to decide which of this combination of between epochs and learning rates is gonna give us the highest accuracy. So the suggested amounts for the first problem are with one epoch and like learning rate of 0.8, which is pretty high rate, till very low, which is 0.01. I already did the learning, but I'm gonna show you to you. So this is the epochs. I wanna give it one epoch, let's say, and let's do it with 0.8, which is pretty high learning, and I'm gonna just have it. I need to run one more time because I already reset this from here, the input. Yes. So, okay, start learning. It's just gonna be one epoch by learning rate of 0.8, which is the highest. So it's done. See, we are getting very low accuracy. It's not even 1% yet. We can change these numbers, and instead of 0.8, I'm gonna give it 0.5. Let's try this. So we're getting better, but not that much. Still 73%. I want to jump to very low rate, which is 0.01. See how it happens here. So still got bad, right? So from 0.8, 0.5, and 0.01, we got, like for 0.8 we got 0.99, for 0.5 we got 73%. Oh, sorry, I already did that. So let's do that one more time to make sure not. Okay. So it generates 74%, which is highest percent here. So if we just draw it like this, 0.01 till 0.8, and this is 5, this is 0.1, so 74.8 generated very bad, 0.99, 0.1 generated 73, and 0.71. So it kind of like goes up and goes down. So it seems that we are getting very good numbers around learning rate of 0.5. So you can play with it. Also, it's suggested to use more than one epoch. Let's try with 3 epochs and learning weight of 0.2. So it's gonna take longer. This is how we decide which learning rate is better and how many epochs is good. But just keep in mind, like 2, 3, 4. These are very low numbers of epochs. Usually, for a good to get a good model, you need to do it maybe very high number. Like, don't want to give numbers, but maybe 1,000. It depends to the use case you are trying. Oh, with this it didn't get any better. It got 0.99, almost the same. So let's try with maybe 5 epochs and learning points, weight of 0.2. Till it finishes, always something that keep in mind when in the I use Ubuntu, so when you run this command to launch your notebook, and then just copy after whatever the port number is. Also keep in mind you can change the port number if you want to when you're launching the notebook. And this is the IP of my EC2. I'm not worried about it because it's gonna just go away next time I'm launching it. So with the epochs of 5, learning rate of 0.2, we got accuracy of 77%, which is pretty high. So see different, trying, not necessarily higher numbers are better, not necessarily higher epochs are more epochs are better, but also keep in mind you can just try and find the best like when your goal, whatever is best to get you your goal. And I hope you enjoyed this, and thank you for watching. And I'm Jean. Bye.